This channel is entirely supported by people like you, liking, commenting, sharing, subscribing, purchasing, and donating. Thank you. A very long time ago, there was no division of knowledge, no reason to distinguish an object's chemical nature from its dynamical nature, nor any means of calculating or describing its changes over time. Today, we are all well aware of the distinctions between a chemistry class, a physics class, and a calculus class, such that we have a basic understanding of what makes them different and what you could expect from taking each class. A chemistry class deals with the chemical elements that an object is made from, and what it is made from can tell us how it will react to other objects chemically. A physics class deals with motion and physical changes that have no changes on the chemical elements of the object. A blending of these two fields would give us something like material physics or a chemical physics. Both of these sciences deal with how an object changes, but they care more about the initial state and the final state, and the science of transformation, the science of change, they leave to calculus to answer. Both sciences, therefore, use the mathematics of calculus to better understand the changes, whereas calculus itself, a mathematical science, drops the context of the objects and deals only with the functions of change over time and how to best measure it. Before we established these distinctions, and long after we have established advanced years of study in each of these fields, we find that there is very little difference between these sciences, and so, for the caveman beginner, and for the mathematical physicist, where to draw the line is blurry. For the caveman, what would give him a reason to assume that what an object is made from should have no effect on its falling motion to the earth? Or, what reason would he have to assume that the force of an interaction is independent of the chemical elements? Clearly, it would seem that falling onto a rocky ground would hurt, but falling into water shouldn't hurt at all because it just flows by, right? Then he belly flops onto the surface layer of water and learns it is equivalent to the ground when, after hitting the water, it makes him see stars. For the scientist, the blurry line comes down to the fact that the deeper you get into what makes up an element, the closer you get to a constantly changing physical stuff, that wibbly-wobbly timey-wimey stuff. So let us go 20 to 30,000 years back, before we established a language but were able to vocalize. What we vocalized at this point were names, actions, and excitements. And by excitements, I mean any emotional reaction to external or internal stimuli. A basic causal association-based language naturally starts out with three things to observe. There are objects, subjects, and actions. Something from the past got the object and subject here together today by some action, and the subject and the object interact together by some other action, and we store this information in the form of memories. We eventually reach this conceptual developmental level where we have these concepts and start using our volitional consciousness to organize these concepts together. Our ability to move our consciousness to units of memories is such that when we recall these causal associations, we can decide to cut off the memory in order to leave a blank, which might be filled by a different memory, which might be false or true. For example, remembering multiple hunts, one of a deer in the forest, one of a mountain lion in the mountains, and one of a bison on the plain. And you recall the parts about grabbing a weapon, leaving your camping shelter, looking for footprints and animal droppings, and then moving in the same direction as that animal, spotting the animal, waiting for the right moment, starting the chase, using the weapon, and ending the animal. The animal changes. The rest of the pattern is the same. So, by neural connection alone, the pattern is stronger and more consistent among the tracking skill neurons, and what is much less consistent or connected are the specific animals. And as such, the concept hunt can omit the specific animal and hold just the memories of the tracking and weapon usage. The consciousness follows the thread of the memory, and when the thread reaches the fork in the road, you get to decide which path to follow. Or you can jump to whatever animal or object or action or concept you wish. This ability to cut off paying attention to the information the brain is sending up allows us to mix and match our memories into whatever groupings we want. This is what imagination is. Imagination is the ability to recall certain units of memory and ignore and remove from conscious focus other sections of those memories, in order to organize or reorganize pieces of our memories into new arrangements that did not occur in reality. Using imagination, we can mentally perceive this new organization, and that is sufficient for consciousness to get the brain to make new physical connections that link those three things: the object, the action, and the subject. Another major cognitive development is the ability to say no. This ability comes from the perceptual requirement of path selection, where a dog you take on a walk can clearly, non-verbally communicate to you that it wants to go this way and refuses to go that way. This ability to say no is far more powerful when it is used by a conceptual thinker, for the dog can only decide no to a path when it is perceptually shown the path, and the memories of that path are then lit up. But humans have the ability to say no to a path before leaving the shelter, having the ability to mentally plan out a set of directions minutes, hours, days, or years in advance. This ability to say no, however, starts a lot simpler than this, and starts at a very early age of language development. A 2-year-old's favorite words are mine and no. If they want it, it belongs to them. If they don't want it, it's coming for your head. At this age, they are unaware that you have a different mind from them and that you don't see the world through their eyes, as they are now coming to understand their existence in this world of objects and have no reason yet to suppose that people existed before they did. So when the toddler learns to say no, they are learning about their relationship to the world and trying out their volitional control over it. This practice of control, however, clashes with the fact that people do exist outside of them. And so, sometimes saying no works, and you get the thing you want, which can only really teach the child that they can get what they want. The other half of that lesson comes from saying no, and not getting that no met the way they wanted. When the toddler is met with a no to their no, it in a sense violates expectations, and the toddler has to double-check their short-term memory to essentially think, "Excuse me? What did you just say to me? What do you mean?" When things don't go our way, we might not have the words for questions yet, but that feeling that comes with confusion and questions is real, and the brain, more or less, craves an answer to what caused this unexpected result. So at some point during human language development, both historically and individually, we started to discover these patterns. And so, when one of these pieces is missing in the pattern, we attempt to fill in the blank by asking such questions as, what is that? Where is that? Who is that? How is that? Why is that? In the very beginning, there was no reason to assume that you are different from anything else in nature. And so, regardless of the very many differences, the basic answer to why things are the way they are and do the things they do will appear similar to the reasons why you are the way you are and the reasons why you do the things you do. So rocks probably roll down hills when they want to, because it makes them happy. you were born, therefore the ground and sky were also born. Something had to have relations and produce them as their children, and so on for all of the trees and rivers and mountains, etc. Religions were formed as a means of answering all of the questions that we didn't have an answer for, by connecting together the abstracted links that are formed by following the questions to various dead ends. Religion therefore constantly struggles, as every new question and every new answer requires that the information not contradict itself, which happens more and more often over time, and eventually the explanation is as hollow as just saying you don't know. Attempts to justify one broken aspect break another, until one day, one person or a group of people decide that this is insufficient and wanted an explanation to what everything is made from, where the answer wasn't whatever the gods want it to be made from. And that was the birth of natural philosophy. Let us thus construct a list of questions, or lines of inquiry, we want answers to without invoking the gods. Why is there an entire section of the world which is just unreachable and constantly just following this one path? Why do we sometimes shake, and sometimes have no water, and sometimes have too much water? Why is the earth shooting fire into the sky? Why do some things have souls and other things appear to not have soul? And not just anima, but even some inanima appear to have a soul. Soul, here meaning acting in a manner which we cannot reproduce by dynamical causal interaction in the same way every time. For example, in animals, you can bring your horse to water, but you cannot force it to drink. Likewise, some rocks have the ability to move other objects without touching them, and we cannot use different rocks and certain movements to match this behavior. So, some rocks have a power we cannot mimic, and that is the current meaning of soul for our investigation. Things, both inanimate and animate, are composed of shapes. Shapes exist, have properties, and can be simplified essentially to triangles and circles. We can use this information to discover new things. For example, if we watch the sky, most of the objects in the sky are just points of light that move in an arc path, and some are circles that move in a similar path but at different speeds. Why do they move? What is the meaning of the path they take? What is the meaning of their shape? And does their appearance in the sky affect our earth shakes and water levels and storms and such? We have no reason at all at the start to assume that the wandering stars and the fixed stars have no impact on us. Maybe their shape or color causes storms on Earth. Can we find out if these things are connected? There are two obvious things which can occur to a conceptual level thinker who uses their memories and volitional control over it to abstract out observable differences. The first obvious thing is that to do something correctly requires that you know the essential characteristics of the thing you are working with. To turn a rock into a knife, you need a rock of a harder substance. A lesser hardness will result in the rock you want to shape shaping the rock you wanted to shape with. Objects exist in a certain way, and if you want to use that object for its purpose, it has to be done in a certain way. If you want a fire, you need wood. If you store your wood in water or where it can get wet, you cannot make a fire. To make a fire, the wood must be dry. If you want to build a shelter, you cannot use straw alone. The house will blow away in the wind. So even a shelter, which does not exist until we build one, has certain properties, even before one is built, which require that a shelter be made of a certain type of material for the sake of a certain type of being that dwells within it. Everything has within it arche, that from which a thing can be known, the genesis of its existence, the source of its motion. From this we can formulate some principles of knowledge. 1. Knowledge of a thing requires understanding of its arche, of its first principles or primary causes. 2. Our knowledge, our principles, are singular or multiple. If singular, it is of a fact of a thing in motion or at rest. If multiple, it is of a relationship between moving things. 3. Our knowledge of things is a knowledge of singular things in motion with respect to other things. For example, to know how to grow a fruit tree requires understanding that fruit can become a fruit tree. Our knowledge of the fruit or of the tree is of their shapes and colors and sensory information, of the facts about the singular objects. And our knowledge of the fruit to the tree is of a relationship between them, and change and time and potential. Our knowledge of growing a fruit tree then is of knowing the motions and changes of singular objects, like the individual fruit and of the tree. As such, then, we can limit our study of the growth of fruit trees into different subgroups, where in one study we care only for the knowledge of the fruits themselves, and what makes them move and change, and of another study which cares only about the trees and their health. The other obvious thing is that things change, which also means that some things at this moment do not change. For if everything was changing all at once, we would not be able to identify it as such, as we would have no stability to judge it against. Thus, at all given moments, some things will be at rest, and other things will be changing. There are 3 principles of nature that we can construct from the start of this pattern recognition of change. 1. Things can change, but they don't have to. Not every acorn becomes a new oak tree. 2. Things change because of what they are, and how other objects interact with them externally. 3. Things change because of what they are, as there is something inside of all things which allows for this change. For example, if you want to plant a bunch of new trees for their fruits, you must first, externally to the fruit, force its movement by taking it from the tree, and physically planting it into the ground. Because of what it is, we can see it, touch it, and bury it. And these fruits can become trees of their own, but you cannot force them to grow. Again, just like you can bring your horse to water, but cannot force him to drink. You can bring a seed to soil, but cannot force it to grow. Something inside it doesn't want to grow. As such, questions emerge like what makes a fruit a good fruit in terms of being a fruit, and what makes a fruit a good fruit in terms of becoming a tree, and is there a difference between those two? If we apply these principles to our questions about the world, we can start to understand our world. Why is there an entire section of the world which is just unreachable and constantly just following this path? To understand, we must find the first principles. Or if that is too hard, we can just identify the individual objects that are involved. And if we can learn their first principles, then we can later find the principles of their motion. We can identify fixed stars, which are stars that are unchanging relative to each other, and wandering stars, stars which change relative to other stars. All of the fixed stars, despite their nearly uncountable number, all act as one, whereas the wandering stars, despite there only being 7, they all act individually, moving at different speeds and appearing at different times of the day or year. The 7 wandering stars are the Sun, the Moon, Mercury, Venus, Mars, Jupiter, and Saturn. Perhaps if we can get a better examination of what these objects that differ are, we'd be able to understand why they move the way they do. The same can be applied to the study of the nature of inanimate objects on the earth, and the study of the nature of animate objects on the earth, and the study of the shape-based nature that they are both made from. Further, we can do so without needing the others. For example, if we wish to study the nature of their shapes, we do not need to know about the motions or colors or purposes of the objects. Just their basic shape and only that. We therefore have reason to construct different fields of study, such that one study is the study of objects in motion, regardless of the stuff that they are made from, and another for what the stuff they are made from is, and another for the way in which both types of studies change as a rate of time, thus opening the doors for us to begin calculus, chemistry, and physics. We begin next time. This channel is entirely supported by people like you, liking, commenting, sharing, subscribing, purchasing, and donating. Thank you.